So this is a case where I'm going to multiply these two series together, two functions in series. And to do that, I'm just going to list out what the terms are. So what does f look like? So I'm going to put a parentheses here for f. And if n is 0, 2 times x to the 0 is 2. And then 2 times x to the 1 is just 2x. And there's going to be a plus 2x squared, 2x cubed, and so on. All right, what does g look like? Well, g says to do an n times x to the n. Now, note if n equals 0 here, the first term is going to be a 0, so that's negligible. So then the first real term is when n equals 1, so I'm just going to get 1x, and then 2x squared, and then 3x cubed, and let's do one more, 4x to the 4th. And we keep going. All right, next think about multiplying. How do you multiply polynomials together? Now these are infinitely long, which is a little bit of a struggle, but we can still do it. The bottom line is you take the first term of the first polynomial and you multiply it by each and every term of the other polynomial. All right, so we're just going to do that. So I'm going to do that first. And then second, I'm going to take this second term and multiply it by each term of the other polynomial. And so on. And then we'll do the third term. Now to do that, I'm just going to stack them. So when I multiply everything in the second one by 2, I'm going to get a 2x plus a 2 times 2 or 4x squared plus 2 times 3, I just leave it as 2 times 3, x cubed plus 2 times 4, x to the 4th, and so on down the road. So that's multiplying by 2. So check, that one's done. Multiplying by these guys here by 2x, what happens there? Well, 2x times x is going to give me a 2x squared. So I'm going to put that under here because it lines up with the right power. And then 2x times 2x squared is going to give me a 2 times 2x to the 3rd. And then 2x times 3x cubed is going to give me a 2 times 3, but x to the 4th, and so on down the line. Let's do another one. Let's multiply now the 2x squared times each of those terms. So 2x squared times x is going to be 2x squared times x can be 2x cubed, so I'll write that one under here. And then it's going to be 2x squared times 2x squared, which is going to be a 2 times 2x to the 4th. And I'll write the other one anyway, even though I don't have them above. 2x squared times 2x cubed is going to be a 2 times 3, x to the 5th. And it's going to keep going that way. And one more time, just for fun, if we take the 2x cubed times each of those, 2x cubed times x is going to be a 2x to the 4th, which will land here. And then there's going to be a 2 times 2, x to the 5th, 2 times 2. And that's just going to keep going. And this is just going to keep going down diagonally like that. But notice at first, there's only one term in the first column, 2 terms in the second column, 3 in the third, and so on. I can add these up as I go along. So I'm just going to add these coming down. And that's going to start building my new one. So I know the first term, the only term with just an x in it is that one right there. So there's going to be a 2x. And then there's going to be the 2 plus 4, which is a 6x squared. Here, we're going to have 2 times 1 plus 2 plus 3 would be one way to think about that. So just note that's going to be 2 times, right? Each of them has a 2 in it. And then there's a 3 plus a 2 plus a 1, x cubed. That's a pattern we've seen before. Let's see, what does that give me? 6 times 2, this one's going to be a 12x cubed. Is there a pattern developing here? This one's going to be a 2 times everything, and then 1 plus 2 plus 3 plus 4 gives me a 10 times 2 is going to be, there's 20 of those there, x to the 4ths. And I might as well write out one more for fun. The next one would have been 2 times 5x to the 5th. And this one would have been 2 times 4x to the 5th. And the next one down here would have been the 2x to the 4th times each of those, which is going to be a 2x to the 5th, blah, blah, blah. And I get the same pattern. All of them have a 2 in it. And then there's one of them, then 2 of them, then 3 of them, then 4 of them, then 5 of them. So that's 5 more or 10 more than I had before. So that is going to be 30, right? Yeah. Plus 30x to the 5th. Okay, can we find a pattern to this? And the answer is yeah, we can factor the 2 out of all of these. And that's going to leave 1x plus 3x squared plus 6x cubed plus 10x to the 4th plus 15x to the 5th. And then note that where did that 3 come from? Or let's pick on the 6. The 6 came from a 1 plus 2 plus 3. Right, so that 6 right there is really 1 plus 2 plus 3. And where did the 10 come from? The 10 was a 1 plus 2 plus 3 plus 4. And where did the 15 come from? 1 plus 2 plus 3 plus 4 plus 5. We've seen this pattern. This came up in math, integral calculus, and it came up when we were playing with sums. That's the sum of the first n integers. So just recall sum as n goes from 1, or actually we should use an I there. Sum as I goes from 1 to n of I is equal to n times n plus 1 over 2. So that right there is my coefficient here with the 2 times it. Whew, that was fun. So this one ends up being, let's see, the coefficient then is 2 times that, right? Because we have a 2 out here. So that means in general, my nth term is n times n plus 1 times x to the n, right? 1, 2, 3, 4, 5, and so on. So, and let's see, if we start n at 0, they want to start n at 0. This would be starting n at 1. So I was saying that is n equals, so is that true? I seem to be off a little bit here. So I was thinking n equals 1, n equals 2, n equals 3. Double check this here. For 3, that would be 3 times 4 over 2, which is 6. Yeah, that works out okay. But they want us to start with 0, so that means we have to increase these just a little bit. So we have to replace n with an n plus 1 to start at 0. So then it would be, if we start, we'll double check this, with n equals 0, that would 0 all of this out, which I don't want. Or does it matter? Oh no, that still works out okay. It just gives us a first term of 0. Yeah, we can stick with this. Let's just double check. So I believe that this should be n times n plus 1 times x to the n. And we should check that. What is the sum as n goes from 0 to infinity of n times n plus 1 times x to the n? And if n equals 0, this will be 0 times all of that. So that first term would be 0. If n equals 1, we'll get 1 times 2 x to the n. That is not quite right, is it? If n is 2, we'll get 2 times 3 x to the n, or x to the, sorry, what did I say? N was there. This is n equals 1. This is n equals 2. when n equals 3, we'll get 3 times 4, x to the third. How does that compare here? Oh, that's correct. 2, and then 6, and then 12. All right, it works. Cool. What's important? Listing out terms. Very important for sums.